this video, I'll be going through the questions from the Chapter 16 Integration 10-year series. Okay, you should have attempted this already based on the last lesson that I have assigned all of you to do when I'm not around. Right, so let's get to it. Question 1. Okay, the curve is such that d square y over dx square is equals to 8 minus 6x, and the point P 2, 8 lies on the curve. The gradient of the curve at P is 3. Find the equation of the curve. Right, so there's quite a few information given to you in the question. Now the whole idea is to break down the question and try to figure out the answer. Right, so in this question they ask you to find the equation of the curve. Right, so what this means is you are looking for y equals to something something, right? That's what equation of the curve is. And what are you given? You're given the second derivative, you're given a point that lies on the curve. Okay, you're also given the gradient of the curve at P. Gradient of the curve at P is 3. What does that mean? Right, that means that the dy over dx is 3. Okay, so you have to understand the question, right? So let's start from what you're given first. You're given the second derivative equation, d square y over dx square. So if I were to reverse this, that means I reverse by taking the integration of this expression, I will be able to get dy dx. Right, so that's the missing word here. We will integrate, okay, d square y over dx square to get dy over dx. So how do we integrate this expression? Right, so you need to look at the list of formulas over here. Okay, so following this list of formulas, in this case the number 8 refers to this one. Using this formula here, I should be able to get it. Got so thin. Okay, referring to this formula, we will be able to integrate the constant 8. It's like x to the power of 0, right? So this will become 8x. And then negative 6x squared over 2. Okay, and then we plus constant C1, where C1 is an arbitrary constant that we need to find. Right, so now before we can integrate it one more time to get our expression of y, we need to find our constant first. So let's look at what we are given. Okay, what are we given? We're given that the gradient of the curve at point P is 3. So what is at point P? At point P, x is 2. Can you see that? So given dy over dx equals to 3 at x equals to 3, we're going to sub that in to find our C1. We'll have 3 is equals to, x is equals to 2. X is equals to 2. Dy dx is 3 equals to 8 bracket 2 minus 6 bracket 2 square over 2 plus C1. Right, and we will solve this expression to give us 3 equals to 16 minus 3 times 4, 12 plus C1. So therefore C1 is negative 1. Okay, so we will get dy over dx is equals to 8x minus 6x squared over 2. I can simplify it to become 3x squared minus 1. So this is our dy over dx expression. So now we'll do the whole thing one more time to get our expression in terms of y, which is what the question wants. Okay, so integrate dy over dx to get y. Okay, so now we integrate each term by itself. 8x first. 8x integrate will become 8x squared over 2. Integrate 3x squared will become 3x cubed over 3. Integrate 1 will be negative x. Then we plus a constant C2. And now we need to find our C2 again. Okay, so sorry, before we integrate one more time, no need, sorry, there's an information that's lapsing here. We need to find the value of C2 to find Y. Okay, so sorry, don't need to integrate one more time already. After you get Y, don't need to integrate already. Okay, so now what information is given to us? We're given that point P lies on the curve, right? So we know that given P2, 8 lies on curve, we just have to sub in Y equals to 8 and X equals to 2 to find C2. Okay, so sub it in and you should be able to solve X cubed, sorry. 3 over 3 just cancels out. Wait, maybe I should also just simplify this. 8 over 2 is 4. So it's 4 2 square minus 2 cube minus 2 plus C2. Okay, so this will end up giving us C2 to be 8. Right, and therefore our answer is Y equals to 4x squared minus x cubed minus x plus 8. Okay, I should also rearrange it such that the x cubed term comes first. Alright, so this is the answer for question 1. Did you get the correct answer? The next video will have answer for question 2.